بسم الله الرحمن الرحيم.
Assalamu alaikum students. Today we are studying unit number 12, wave and sound. You have discussed some of the topic previously of some starting topic of this chapter. We are starting from wave motion. Okay. So according to the name wave, we all know about the wave. What is wave? So we are discussing how wave travel, how wave form motion, and how wave does motion. Okay. So first of all, starting from an example, just suppose we have a ripple tank. Okay. What is ripple tank? Ripple tank is a simple tank like aquarium. We have a glass tank and it is filled with water. So if I put a pen in that water, inside that water, dip it and take it out, what will happen? Some of the ripple will form. Ripples are like, just suppose I have a surface of water, okay, and I am dipping a pen, so some of the movement like this will occur. So I am calling this movement as a ripple. So what will happen, as we dip the pan, some of the ripple will form on the surface of the water, and that ripples are simple example of the wave. Just suppose I am putting a paper. I am putting a paper on the surface of the water. So now I am dipping the pen. So what will happen? As a ripple will form, that paper will move with the ripple or not? That paper will remain at its place. It will move up and down, but it will not move to the end of the surface. It will remain on its original position where it was, but it will move up and down. It means what is happening? Waves are forming, disturbance is happening, but that disturbance is only traveling across the surface. It is not moving the water away from that surface. That is why that paper is remain on its place. So wave, simple example, how wave form? We have a ripple tank, we are dipping a pan or any object in that water, dip and out, taking it out, so ripples are forming. These ripples are the example of wave. I have another example. This example is also given in your book. Just suppose you have a long string, okay, and what you did, you fix one end of that string with the wall. Now you are holding that string from there. Now what you are doing? You are doing like this. You are creating the disturbance. You are vibrating your hand and creating the disturbance to the string. So what will happen? A motion like this will produce. So we can say this is a wave. Getting class? So now I am giving you the basically the concept of wave. Okay, how many waves are there? So we discuss an example of wave. We discuss another example of wave. I have another example of wave. Just suppose you have a spring. Okay. So what you are doing? You have a spring. You fix one end of the spring from the wall. Now what you are doing? You are pulling that spring. So as you pull that string, what will happen? That spring will extend. This what happened? So as you, just suppose here is the diagram and this is the spring. Okay, if you pull this spring from there, from that side, so what will happen? That spring will extend. As you leave the spring, so what will happen next? There will be some compression and rarefaction. What I am saying, rarefaction and compression, and what are they? Just suppose I am showing it with diagram, not like this. Just consider the movement of this part of the spring like this. From some places it is like this, then it will extend, then like this, then again it will extend. As I pull the spring and leave it, so what will happen? It will contract first, then again expand. A little bit repulsion of expansion. This would happen because it's with repeated motion. Getting class? So as I leave the spring, it will form some of the waves, and these waves are like compression. Compression means where the pressure. If I talk in term of pressure, so in compression, pressure is slightly higher than the pressure of the atmosphere. You know about the pressure of the atmosphere, I think you studied it in chapter number 8. So what is chapter number 10? So what is compression? Compression is a point where air pressure, inside pressure, is slightly larger than the air pressure. Okay, if I talk about the rarefaction, so here, because it is expanded form, so here the here pressure is slightly lower than the air pressure, surrounding pressure. Getting class? So these are the three types of motion, we can say. These are the wave motion. If I talk about the how many types of waves are there, so we have two types of wave. We discussed two types of wave. First one is the transverse wave, and the second one is the longitudinal wave. Transverse wave and longitudinal wave. So what is the difference between these two waves? There are some other names of these two waves. Transverse wave, we can say simply light wave. The example of the transverse wave is light wave. Longitudinal wave, the example of longitudinal wave is sound wave. So what is the difference between these two waves? You are clear about the wave, what are waves? So wave form by the disturbance of any object. If any object is vibrating or creating a disturbance, that disturbance travel along the path, so what will happen? Wave will form, and that motion is known as wave motion. So we have two types of wave. The first one is the transverse wave and the second one is the longitudinal wave. So what is the difference between them? Showing you with the example. As we talk about two example, I am just repeating that example. Just suppose you have a string and one end of that string is fixed with the ball. Okay, so you are holding that string from there. Now what you are doing? You are doing a motion like this. It means you are creating the vibration. Look at my hand. I am creating the vibration in this direction. First I am going upward, then I am going downward, isn't it? So what will happen? String will behave like this. Okay, so what will happen? A wave will produce, and look at the wave, look at the displacement of the wave. That wave is going away from me. Just suppose I am repeating the motion. This is my hand, I am holding the string from there. Now I am doing the vibration like this. Okay, I am moving this string like this. I am creating the vibration in upward and the downward direction. But where is the displacement going? Where displacement is away from me. If I look the angle between the vibration, mean the disturbance, and the displacement, what will be the angle class? It is like this. I am creating the vibration in this direction and displacement is in this direction. So this angle is 90 degree, or we can say it in another word, perpendicular. So a transverse wave is the wave where the displacement of the wave, the disturbance of the wave is perpendicular to the source. Source mean my hand was vibrating in this direction, so my hand was source, that source which was producing the wave. Okay, and the displacement was 90 degree from the disturbance. So whenever you have a displacement which is perpendicular to the disturbance of the source, then that wave is said to be transverse wave. Getting class? And a common example of transverse wave is light wave. Light wave always travel like transverse wave travel. Getting class? Okay, now moving to the longitudinal wave. As previously I discussed example of a spring. Also consider the difference between them. Okay. So in this situation, I was holding it from there and creating the vibration like this. But in this condition, what I am doing, I am pulling it from there. So okay, now what will happen as I leave? So what will happen? Wave will this spring will displace in the same direction as this was, but the difference between them is when I was creating the wave over there, I was creating the disturbance like this. So vibration is like this and displacement is perpendicular. Now in which direction I am producing the vibration? In this direction. Getting class? So in this direction I am creating the vibration, mean I am pulling that spring. Now what will happen is as I leave the spring will when I pull the spring, it will expand. When I leave the spring, it will again contract, then expand it. So what will happen? A rarefaction compression, rarefaction compression. This is how the wave form. Okay, and that wave is known as longitudinal wave. A simple example of this wave is sound wave. Getting? Just suppose I have an object. Okay, this object. What will happen if I am vibrating it like this? So what is happening? This object is striking the molecule of the air, and that molecules are also producing the wave. Okay, so I am vibrating it like this. So the displacement of the wave is not in this direction. If I am vibrating it like this, mean I am vibrating it in this direction, right and left. So what will happen? This marker will strike the molecules of the air, and that molecules of the air will produce the further wave motion. So where will be the displacement? Just suppose this is a molecule of the air and I am vibrating it like this. It will hit this molecule and this molecule will displace in this direction. It's mean in the direction of the vibration, where the disturbance, where in this direction where I was creating the disturbance, the molecule will go in the same direction. Getting? So longitudinal wave is a wave in which the direction of displacement is parallel to the direction of the disturbance or the vibration of the source, we can say. Getting class? So the difference between transverse wave and the longitudinal wave. Transverse wave always travel perpendicular, displacement will be perpendicular. Longitudinal wave displacement will be parallel to the vibration of the source. We have the example of transverse wave, which is light waves, and we have the example of longitudinal wave, which is sound wave. Getting? So sound waves always travel like longitudinal waves travel. Okay. Now we have some terms related to the wave. Here I draw a diagram. This is a wave. Okay, and now I am explaining some of the terms according to this wave. Basically, this topic is under the heading of characteristic of wave. So first one and the most important one, amplitude class. Just look at the mountain which are formed by this wave. Peak point. This one is the peak point of this cycle. This one is the peak point of this downward cycle. Then again, if I talk about the upward cycle, this is the peak point of this cycle. So what is amplitude? So what I am doing, first look at the wave, how I am forming the wave. Like I formed in transverse wave. Just suppose, just consider I am forming this wave like I formed in transverse wave. What I was doing, I fixed the end of a string from the wall, and from the other end I was creating the disturbance like this. Okay, so this types of motion will occur. So first it will go upward, cycle will go upward, reach to the maximum point, then it again come downward, reach to the maximum point, then it again go to the upward. As my hand was vibrating in this direction, so the wave was forming in this direction. Okay. So this maximum point, if I talk about this line, so the distance this distance is known as amplitude. Okay, so highest maximum distance reached by highest maximum peak point reached by a wave during a cycle is known as amplitude. So this is amplitude class. Getting it? Now moving to another term. These are the characteristics of wave. If I discuss the wave, so which things we discuss, I am discussing about these terms. Okay. So first one is the amplitude. Now moving to the second one, just consider the motion from. Okay, tell me how many cycles are there? One. Look, from this point to this point, this is one complete cycle. And if I talk about this point to this point, this is second complete cycle. Okay, so first cycle and the second cycle. So two terms are there. Frequency and time period. These two terms related to each other, but there is a difference between them. First, I am talking about the frequency. Okay, so frequency must always be per second. It's mean, just suppose this is a wave and this wave is forming in 1 second. So how many cycle are forming in 1 second? Mean how many cycle wave does in 1 second. So in this case, if this wave is traveling in 1 second from that point to this point, so the frequency is 2 cycle per second. It means a frequency is the cycle which is formed by any wave per second, per unit time we can say, because SI unit of a time is second, so that's why I am saying per second, but we can say unit time as well. Getting class? So frequency is number of cycle produced by a wave per second is known as its frequency, and the unit of frequency is obviously cycle per second, or in other terms we can say it in hertz. This is the SI unit of frequency. We measure the frequency in hertz. Okay, that's why we most of the time if we talk about the charger, a mobile charger, it is written on that charger 50 to 60 hertz. So 50 to 60 hertz, what is 50 to 60 hertz? It's the frequency of the current which is coming from the line. Now moving to the time period. What is time period? Just suppose we were discussing about the frequency per second, number of cycle per second. So that was the frequency. Now moving to the time period. How many cycle? Okay, not how many. One complete cycle. In which time a wave complete one cycle. That will be its time period. It means just suppose what is the complete cycle? Upward down complete cycle and the downward complete cycle. I will call it as one complete cycle. Okay, so it is starting from there and coming down again to the mean position, and now moving in the downward displacement. So from this point to this point, it is one complete cycle. Okay, so if it complete in which time it complete one cycle, so that will be a time period of that wave. Getting? So time period is complete cycle in how much time? Per unit time we can say a complete cycle in which time is known as the time period of that wave. Getting? Okay, what we have left? Wavelength. Okay, we have the point, sum of the point. This peak point in the upward direction, this is known as crest, and this is known as trough. Okay, crest, trough mean the upward side, the upward highest peak, and another term amplitude, the highest amplitude gained by a wave is known as, in the upward direction is known as crest, and the downward highest maximum amplitude gained by a wave in the downward direction, that is known as trough. Okay, so the distance from one trough, one crest to another crest, we can say it wavelength, as a wavelength. Okay, or the distance from one trough to another trough, this is also the wavelength. Okay, so the distance between crest to crest or trough to trough, this is known as wavelength, and we represent this wavelength by the sign. This sign is known as lambda. Okay, so this is the symbol of wavelength. As wavelength is length, so what will be the SI unit? Meter, obviously. Last thing. For that, I am removing this. Okay, wave speed. From the name, it is clear that we are talking about the speed. In normal term, what is the formula of speed? In the normal term, the formula of speed is distance upon time. This is the formula of the speed. But as we are talking about the wave, so what I am changing these terms in these terms, because we are talking about a wave and the characteristics of waves are these. So distance, I will replace the distance with wavelength. Okay. Now upon time, time mean time period. We have a small derivation. Just suppose this is a wave speed, denoting it with V, and we are clear that V is equal to wavelength upon time period. So I am writing the symbol of the wavelength, and now the symbol of the time period. Getting class? But as we know, there is a relation between them, frequency and time period. And what is the relation? Frequency is equal to 1 upon T, or we can say T is equal to 1 upon F. So I am using this relation. This is a relation between frequency and the time period. Frequency is equal to 1 upon T, 1 upon time period, and time period is equal to 1 upon frequency. So I am using this relation over there, mean T is equal to 1 upon F. I know this, so I am putting the value of T over there, here 1 upon F, putting V remains same, lambda remains same, but in the place of T, what I am doing, I am putting 1 upon F. Okay, here F is dividing. When I shift it to in the numerator, what will happen? It will multiply. Okay, it will be easier to you if I write it like this, divide 1 upon F. Okay, what I am doing, I am changing this division sign. It will become multiply, and as we know, whenever we have to change this division sign, what will happen? This factor will reciprocal, mean F will become the numerator and 1 will become the denominator. So 1 F upon 1. Now they both will multiply. V is equal to F lambda. So this will be the formula of wave speed. V mean wave speed, F mean frequency, and lambda mean wavelength. Getting? So in this, by using this formula, we can easily calculate wave speed of any wave, from which speed it is traveling. Getting, students? Okay. So repeating it once again, amplitude, highest point reached by a wave. Okay. Highest peak point, we must say. Frequency, number of complete cycle in per second, in 1 second, in a unit time. Time period, in which time a wave completed 1 cycle. Okay. Wavelength, distance from crest to crest, distance from trough to trough. Getting? Okay. Now wave speed. Wave speed is the speed of the wave, from which speed a wave is traveling. We have the formula for that, which is V is equal to F lambda. F is frequency and lambda is the wavelength. And we did it with this short derivation. We find the formula with this short derivation. It is given in your book as well. Okay, now we have two numericals, two problems, and we will discuss each of them one by one. So first of all, I am raising the board. These two problems are related to the wave. In the first problem, we have to find, I think, time period. So the problem is on page number 238. According to the previous book, it is on page number 238, problem number 12.1. Okay, so I am reading this problem and maintaining the data. Okay, so what is the question saying? A sitar is a musical instrument. A sitar string vibrates at 400 hertz. So whenever we have to maintain the data class, we have to consider the values which is given in the question. Okay, and how we categorize the value? Okay, what value is given in the question? We will categorize that value by the unit. we have to consider a unit. We will realize what value they are talking about, which thing they are talking about. A sitar string vibrated 400 hertz. So they are giving the unit hertz. It means 400 hertz is the frequency, because I told you that hertz is the unit of frequency. So 12.1 data. First thing they gave us is the frequency, which is 400 hertz. Now moving to the question, what is the time period of this vibration? It means they are asking for the time period. What will be the time period of this vibration? Okay, so first of all I have to consider what they are giving and what they are asking. Now the second thing I have to consider which formula have these two values. As I told you before, the relation between frequency and the time period, what was that relation? Frequency is equal to 1 upon t, or we can say time period is equal to 1 upon f. This is the relation between frequency and time period. So what I have to do, I have to just put the values and get the answer, because we are directly given with the value of frequency, so we don't need to convert it in any SI unit or any other thing as we did in previous chapter. This is a simple numerical. So what you have to do, we have to just put the value of f, which is 400. I am putting it the value of f mean 400 in the place of f. So t remains same, is equal 1 remains same, divide sign remains same. Now putting the value of f, which is 400. Getting class? So what I have to do, just moving the decimal, we can do it by the calculator, or if what will be the answer, 2.5 into 10 raised to power minus 3. Okay, because this is the time period, so the unit of the time will be second. Okay, so you have to do this calculation by the calculator. By the help of calculator you can do it manually as well. Getting class? Any problem in this question? A simple one. But whenever you have to do a problem, just keep in your mind, first you have to maintain the data. Okay, then you have to consider the formula. Then you have to consider the formula, which relation is between the data and the remaining thing which they are asking. You will put that relation, then put the values, then after think for the values case, there any value which is from other system, then convert it into the system which are the remaining values are given in which, then put the values like frequency I put. Okay, now the calculation simply. Another thing in the last, like I get the answer of time period. Okay, so this is must unit, and unit with the answer is must, so the unit of the time period is second, so I put second over there. Getting class? Okay, moving to another example which is on the same page. Okay, what they are saying, a sound wave of frequency of 14 hertz. Again, what is given? Frequency 12.2 data. First of all, they give us frequency which is 400 hertz. Okay, and a wavelength of 3 meter. Okay, another thing, they are also giving us the wavelength which is 3 meter. Passes through a certain medium. Calculate the velocity of the wave in that medium. So what is happening? A wave is passing through a certain medium with a frequency of 400 hertz and a wavelength of 3 meter. So what they are asking? They are asking for the speed by which that wave is passing through that medium. Okay, so what I am doing, first I put the data according to the question. I maintain the data. These three things are there. These two are given, and for this one they are asking. They are asking for the wave speed. Okay, now solution. So again, first of all, we have to think for the relation, which is the relation between these three terms, which is the formula. So as I did in the last of the previous topic, that was wave speed. So what was the formula? Wave speed is equal to frequency into lambda. It means wave speed is equal to frequency multiplied by wavelength. This is the relation. Okay, now we know the relation, we have to put the value, but before putting the value, first consider the unit. Hertz. Hertz is the SI unit of frequency. Okay, we can go with this value. What about the lambda? It is given in 3 meter. Meter is the SI unit of length as well. It's mean they both are in SI system, so we can go with these values. So putting the value of frequency, v remains same, is equal remains same. In place of frequency I am putting 400. Now in place of lambda I am putting 3. Okay, what I did, in the place of frequency I put 400, in place of lambda I put 3. Now what is happening? There is no sign between them. There is no sign between them. It means there is a sign of multiplication. So these two values are multiplying with each other. So I am multiplying them. 4 3s are 12 and 00. This will be the answer, class. Okay, again in the last we have to keep in mind, okay, we have to put a unit. This is a wave speed. So what will be the unit of wave speed, class? Speed, unit of speed is meter per second. So the SI unit of speed is meter per second. Getting, class? Okay, in your book it is written like this, so don't be confused. It is written like this, the unit meter per second, it is written like this. So don't be confused, because if I write meter per second, so what is the power over there? Nothing, mean 1. If I shift this second to the numerator, so according to the rule of math, what will happen? Power will become like this. So they both are same, don't be confused. Okay, so meter per second or meter per second, we can say meter second inverse. So this was the problem number 12.2. Okay, so now moving to the homework. You have to copy problem number 12.1 and 12.2 from the lecture. Okay, you can copy it from the book as well, and you have to read all of the topics which we discussed today carefully, because I only gave you the lecture. There are some more details which you will find when you will read it from the book. Okay, so you need to read all of the topic which we discussed today from the book, chapter number 12, and copy the problem number, example 12.1 and 12.2 from the book. It is on page number 238, class. Okay, Allah Hafiz.